Hello everyone. So today let's solve the problem bare and the square grid, right? So this was asked in the code forces around 356 for the division 2. You can just go through the question. It's easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem, right? So I'll just summarize the question, right? So let's see what the question states here. We have an n into m grid, right? Sorry, n into n grid, right? So I'll just go with here. We have an n into n grid where each cell is empty, where each cell is empty represented by the dot, or it is blocked. Blocked is represented by x here, right? So we may choose 1 k into k square. We may choose 1 k into k square. Simple, right? So we have an n into n grid where each cell is empty dot or blocked x, right? So we may choose 1 k into k square inside the grid, right? So we make this one choose 1 k into k square fully inside the grid and turn every x inside it into double dot. Turn every x inside it into double dot, right? So this one I can just write it in this way, x into double dot. Just remember this one. Two empty cells, right? After the single change, what is the maximum size of the largest connected component? Largest connected component of the empty cells, right? So that we need to compute basically four directional connectivity here. So we are dealing with a four directional connectivity. Again, I'm telling. So after the single change, what is the maximum size? Nothing but the number of cells of the largest connected component of empty cells, nothing but the four directional connectivity. So we have to compute the maximum possible. See here, we have to compute maximum possible here, maximum possible size, basically maximum possible size after at most 1 k into k destruction, after at most 1 k into k destruction, 1 k into k destruction, right? So this is the question mainly. So let me read the question out loudly. Just listen to this. We have an n into n grid where each cell is empty represented by the dot or block, nothing but the x, right? So we may choose 1 k into k square and turn every x inside into this one double dot, right? So this is fine. Now, after that single change, what is the maximum size of the largest connected component of the empty cells that we need to see? And this is four directional connectivity. And what we need to compute basically, we need to compute the maximum possible size after at most 1 k into k destruction. Again, destruction, right? We need to compute the maximum possible size here, maximum possible size after at most this one 1 k into k destruction, 1 k into k destruction. So this is the question basically, right? This is the question, right? So see here, we have been given grid here, we have been given grid here, n into n grid, right? So the output here, the maximum possible size after at most 1 k into k destruction is 10 here, right? 10 here. So this is nothing but the n and this is nothing but the k. K we have been given 2, right? So we can turn x into double dot basically here, right? So here we have been given k3. We can turn x into triple dot here, right? So this is nothing but the 5 size, right? Size 5 into 5 basically. n into n grid in the sense here 5 rows and the 5 columns. You can check here. The same thing goes for the input 1 and 2, right? So this is fine. Now they have showed us diagram as well here. You can just look into it, man. Yeah, it's very simple to understand. Now this is fine, man. Let's do one thing. Now we have the idea on the question, right? So idea on the question. Now we have the idea on the input output as well. Let's do one thing. Let's quickly discuss the approach followed by the complexities, and then let's write the code. As usual, let's discuss the approach first. So we are going with the first example that they have given in the question. So this is nothing but the n, this is nothing but the m, right? So this is nothing but this indicates 5 into 5 grid, right? So rows and the columns basically. You can just check this one. The output that we need to get here is 10. 10 basically, meaning the maximum possible size after at most 1 k into k destruction is 10, right? So this is fine, man. First, let's move on with the this one step-by-step explanation. Now, this itself I have written this one. I have elaborated this one here, right? So neatly I have written on that. So you can just get into it. I mean, you can just read this one. You can just have a look into it. So I'll just pause the video and have a look into it, right? So next, the first step here would be we have to identify the initial empty components before moving into this, but step-by-step explanation. One thing I have to tell you here is we will be solving this problem using the disjoint set union data structure, right? Union find basically, right? In simple terms, union find, disjoint set union with a path compression, right? So first step here would be we need to identify the initial empty components and their sizes. Initial empty components and their sizes. See here, this is component A. So this is component A, this is component B, this is component C, and this is component D, right? So this is component D and this is component E, right? So 5 into 5 we have, right? Now, so in the component A, we have this one 0, 1, 0, 0 and 0, 1 are empty. Empty are represented by the dot and blocked are represented by the X, right? So you can clearly see here, right? This is fine, I believe. Component A consists of 0, 1 and 0, 0, which is of sides 2. Empty components we are considering. In the component B, we are considering this one k equals to 2. So we have to go with component A. Component B consists of this one 1, 2, which is empty basically, right? 1, 2, which is empty, right? So here 1, 2 is empty. So this is size 1. So this is size 2. This is size 1. Component C consists of this one. What do we call? 2, 1, right? So 2, 1 here, right? So this one we are considering component C as well as the component D at the same time, right here. So this one component C, let's consider in the same way, man, right? So this one, let's go with the component D basically, right? So component C and component D here, this one 2, 1, 3, 1, 3, 2, and 3, 3 are empty. You can clearly look into it, meaning wherever we have dot, right? So this one 2, 1, 3, 1, 3, 2, and 3, 3 we have dots here, right? So this part, right? So this is of the size 4. For the component D, we have 4, 4, which is empty. See here, the dot, this one, right? So this part we have empty. Now, so we have here this one for the component A, this empty, this one, what do we call empty components are of size 2. So for the component B, it's size 1. For the component C, it is size 4. Component C, we are going with the 2 as well as the 3. Meaning row 2 as well as the row 3 we are considering at a time, right? So this is of size 4. And for the component D, we are considering size 1. Total, do the total here. 2 plus 1, 3. 3 plus 4, nothing but 7. So this will be size 2, 2 plus 1. So this is size 4, this is 1. So here 2 plus 1, 3, 3 plus 4, 7, 7 plus 1 is 8. Total empty cells is 8 we have, right here. Now let's move on with the second step here. So we will be considering every possible 2 into 2 square, right? Every possible 2 into 2 square. For the chosen square, accordingly with the question, converted x. So this one, converted x basically, dot, right? Dot we are considering. This adds k into k, nothing but 4 cells. Yeah, we know this one. Simple. Additionally, the newly clear this one cleared square may connect neighboring this one components. Neighboring in the sense outside square components, right? So into the big component, into the big component. To avoid the double counting, what we'll do, we'll this one subtract any component cells that already already lie inside the square, that already lie inside the square. The best square is the one with a top left at 1 comma 0, nothing but 0 based, right? So nothing but this is 0 based. The 2 into 2 square consists of one empty cell of C, right? It removes 3x's. It removes 3x's basically, right? So inside square becomes 4 empty cells. It connects the component A, B one cell and the remaining outside part of C, right? So when we apply the same thing to whatever we have discussed, total after merge is basically 4 square, right? 4 square. See here, basically inside the square becomes 4 empty cells. It connects component A, 2 cells, nothing but B one cell and the remaining outside part of C. You can just check in the grid. You can just pause the video and have a look into it, right? So total after merge, you can just this one, you'll get 4 square, right? 4 plus 2 plus 1 plus 3. 4 square actually, 2a this one, component A. So this one component B, and 3 rest of C. For the C, we are considering this one row 3 along with the 4. Row 3 along with the 4, right? So this one 3, rest of C. So total this one will be 4 plus 2 plus 1 plus 3, right? So this will be 6, 7. 7 plus 3 is nothing but the 10. So this 10 will be returning this one as the output, right? So the answer is 10 here, right? So the answer will be 10 here. So the output that we got here is 10, which is equivalent to the output that they have mentioned for the example within the question, example 1 within the question. So our approach works absolutely correct here. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n square k and big of n square respectively, right? So now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. Now let's start writing the code. Let's do one thing. Yeah, let's start writing the code. So we'll be making use of this one fast input output along with the this one different utilities, right? So let me import here java dot input output package basically dot star. So this is fine. Yeah. Uh, Now let's do one thing. Let me import here java dot this one. What do we call util dot star. This is fine. Yeah. Now let's go with a class main as usual. Right. So you can just keep any name that's relevant. I'll just give main here. First, let's go with the initialization part, man. We have to go with the grid size as well as the square size, right? Nk variables. I'll just go with the variables n and k. Static and n along with the k. And the second one here is ij. A of ij is nothing but this has to be equivalent to the true, means cell is empty dot. So let's go with the m first here. Static boolean. So this is fine. M, right? So the next one here would be, so let's go with the DSU parent array, nothing but the disjoint set union parent array, component sizes along with the counts inside the current component, right? So this is fine. So I'll just go with here static and so this one will be parent size as well as the inside. So this is fine. Yeah. Now let's go with the component. So let's initialize the component. I'll just go with static int. So let me go with, so this is fine as well. Next, let me go with the static here. Boolean used. This is also fine. The next part would be, let me go with the array list of used component roots, right? So I'll just go with here static array list, right? So the type integer, fine. Let me go with use list. This one equals new array list. Yeah, this is fine. Yep. Now let's do one thing. First, we, as I've said, we'll be going with a disjoint set union, right? So we have to go with a method find. Find will be what we'll be doing within the find. So we'll be going with a DSU find with a path compression, right? So we have to find the representative or the parent, right? So this one, I'll just go with the static and find. This one is fine int x, right? So this is fine one. Now, so within the this one, I'll just go with return. This is fine parent of x, if it is equal to x, then it is fine. Let's display the x, else let me go with parent of x. This is fine, is equal to find of parent of x. This is also fine. Yeah. Next, let's do one thing. Let me come out of this one entirely. We come out of this one entirely. Now let's go with a union helper method. Why? We'll be going with a, we have to go with a union by rank, right? So for this one, this particular problem, we'll be going with a DSU union by size actually. We have to attach the smaller to the larger. So we know, if you know the algorithm pretty well, right? So that's what we'll be doing within the union helper method. So I'll just go with void here. This is fine. Union. So this one will be int a comma int. Yep, this is fine, I believe. So now within this method, let me assign a to find of a. This is fine. B to find of b. This is also fine. The next thing is if A equals B, then we have to exit in that case. Let me give a return here. Also, we have to ensure A is the bigger component here. If size of A here, if size of A is less than size of this one, what do we call? Size of B basically. Then what we need to do? Actually, we have to ensure A is the bigger component, right? So let me assign T to A here. This is fine. A to B here. This is also fine. And B to, right? Now let's do one thing. Yeah, let's attach B to A. So all I have to do here is parent of B. Let me assign this one to the A. Also, let's update the size of the root A by writing like this size of A here. So this one equals size of A plus size of B. Size of B. Right? So this is fine, man. Yeah, let me come out of this one entirely. Now let's move on with the next helper method, nothing but id. So we have to map the 2D, nothing but I comma j to the 1D id, 2D id to the 1D id, right? So let's do that. I can just write it on this way: static int id, sorry, id. So this one, let me go with the parameters I and j. This is fine. So within the ID helper method, let me return. We are converting 2D ID into the single ID. This one, right? 1D ID basically. So this will be 1 into, sorry, I into n plus j. This is fine. Let me come out of this one entirely. Now let's add or remove from inside, right? Count for the component that contains I comma j. Let me go with what should we go with increment? Let me go with inc. I'll just go with static void and see. So this one, let me go with the parameters. We need I, j as well as v. This is fine. Yeah. So within this method, let me go with a simple if condition here. If I less than 0 or j less than 0 or I greater than or equal to n or j greater than or equal to n, this is fine. Then let's we have to exit on that case. Let me give return here, right? So this is fine. So if out of bounds, then we have to ignore, right? So we have to exit on that case. This is nothing but the boundary check man. Yeah. Now let's. So what if? Hmm, what if the only cell? I mean, only if the cell is empty, then we have to adjust the inside counter, right? So that one also we have to consider, man, or else we'll get the error. So let's do one thing. Let me write the simple if condition here. If this one m of I j, if m of ij, then let me go with here inside this one, inside of this one. I'll just go with find. This is fine. Find of id. This is fine. I comma j. This is fine. Yeah. Find of id. I comma j have given. This is fine. Let me do one thing. Inside of find I have written, right? So this one, let me change this one to the square bracket one. So here this is fine. Let me give this one equals the same thing plus v here. This is fine. Yeah. Now let me come out of this one entirely. We are done with the INC method. Now let's go with the add method. Yeah. Add and clear we have to go with basically. So add method, because we will be trying to add the component that contains this one I comma j to the current answer. We need to return the number of cells to add, right? So nothing but size of root, which is equivalent to the size of root minus inside of root, basically outside square cells. Right? So how can I write that one? Let me go with first static int. Later we can think actually. So let me go with the parameters I int j. So within the add method, first thing, let's go with a simple if condition here. Uh, let's check. Let's go with a boundary check man. If it is out of bounds, then we have nothing to add, right? So I'll just go with. Let me copy paste the same thing, or let me write this one. Greater than or equal to j, greater than or equal to n. So this one itself we have to write. Again, same thing. Boundary check, right? So let me paste this one over here. Come to the next line. So here, if we have the blocked cell, then we don't have any component, meaning no component, right? So I can just write it over. I can just write it like this. Amount of m here, of ij, right? So this one ij. Then in that case, we have to return 0, right? So this is fine. Next, let's move on with the let's go on with the root of the component. Root of the component in the sense I'll just assign R to find of this one id of I comma j. So this is fine. Yeah. Now let's do one thing. Let's go with the if condition. Meaning here, if it is not yet counted for this particular square, then we have to mark as used. Remember to clear the clear this one later, as well as contribute only outside square cells. These things we have to do, right? If it is already counted, then we can directly give 0, right? We are considering if not yet counted for this particular square. So I can just write it like this. If not of used basically of R, used of R, then used of R. So this one, let me assign this one to true. This is fine. Now then I'll just go with used list here dot add of R. So this is also fine. Next, let me go with a use list again. Not use list actually. This time we just have to return this one. Size of R. What did I say at that point of time? Size of R minus inside of R, right? So I believe, I hope this works, man. Yeah. Finally, let's return 0 here, right? So finally, let's return 0. If already counted, we have to return 0. So let me come out of this one entirely. We are left with only one helper method. Now we have to go with a clear, basically. We will be going with a clear helper method because we have to clear the used markers for the next square evaluation. We have to move on with the next square evaluation. We have to clear the initial one, the current one, actually, not the initial one, markers for the next square evaluation, right? So I'll just go with static void clear. It's fine. So within this helper method, so let me do one thing. I'll just go with a for loop here for x of used list. So this is fine. Used of x. Let me assign this one to false, right? So now let me go with used list. So this is fine. Dot clear. Dot clear, right? So this is fine. So let me come out of this one entirely. Now let's move on with the main method. Main method, yeah. So I'll just remove this one and let me scroll this one up so that we can see this one properly. I'll just go with throws, sorry, exception. Will be I didn't throw the error. Right. So now let me copy paste the input output part, man, so that we can move on with the logical part. So I'll just paste it over here. Yeah. So we have just went with the buffered reader and the print writer for the fast input and output. And this is string tokenizer for reading the first this one first line input, right? So n and k we are going with. Basically, n is nothing but the grid size, k is nothing but the square size. And uh, in our case, it was basically 5 and 2, right? So this one I'm speaking of, n is 5 and k is 2, right? So we have successfully passed that one. It is in the form of integer, right? We're just passing this one as an integer. This is fine. Now let's allocate the grid. Let's move on with the logical part. So let's allocate the grid. So I'll just go with m equals new boolean of this one n into n. This is fine. Yeah. Now let's do one thing. Let's move on with the for loop here. This one int I equals 0, I less than n. So let's continue here. Sorry, I'll just go with I plus plus. So this is fine. Within the for loop, so let's read the new string. So I'll just go with string here. S equals buffered reader dot read line. So this is fine. Buffered reader dot read line. Now, let me go with a for loop again, the iteration part. So this one will be j equals 0, j less than n, j plus plus. So within the loop, for loop, if it is true, then uh, uh, it has to be true if the cell is empty. Sorry, right? So I can just write it in this way. If m of ij then it will be s dot char at s dot char at. So of j, let me assign this one to the dot. This is fine. Yeah, let me come out of this one entirely. Now let's do one thing. Let me go with a DSU parent for the every cell. Let's go with this one initialization, right? Let's go with the DSU parent for every cell ID. Nothing but parent here. This one new int of n into n, right? So this is fine. Next, let's go with a size that is equal to new int of size n into n. This is also fine, right? So let me send this one to the multiplication operator. Yeah. Now let's go with a variable inside. This is also new int of n into n. So this is fine. The next variable will be going with a used as well as the component, right? Used new. So this will be of the type boolean. Again, the same thing, n into n, right? So the final one is component. So this one will be new int of n into n. This is fine. Yeah, let's move on with a for loop, man. Yeah, let's move on with a for loop. So I'll just go with for here in I equals 0, I less than n into n. This is fine. Let me increment I here. So within the for loop, we are just initializing the DSU here, right? So each cell is its own parent initially. We know this one. So I'll just give here parent of I. Let me assign this one to I. And also let me go with size of I. Let me assign this one to the value 1. So let me come out of this one entirely, man. Now let's do one thing. Let's go with the 4 direction deltas for the neighbors, right? So I'll just go with here int. So dx equals this one comma. So we have to go with the 4 direction deltas, right? So I'll just consider 1 minus 1 uh 0 as well as the 0, right? So this is fine, man. Yeah, again for the y, so let me go with dy. Yeah, this one will be 0 comma 0 comma 1 comma minus 1. So this is fine. Yeah, now let's do one thing. We have went with the 4 direction deltas for the neighbors, right? So now let's do one thing. Let's go with the union adjacent empty cells to form the components. Let's go with the 2 for loops here. So this one will be for int I equals 0, I less than n. Let me go with I plus one more for loop here for int j equals 0, j less than n, j plus. So this is fine. Yeah. Now we have to consider only the empty cells initially, right? So if not of m of I j, then we have to skip this. So I'll just make use of the continue keyword. Now uh, I'll just go with int oi. Sorry, not oi. Let me go with the ni. Right. So this is fine. Ni equals I plus dx of d. This is fine. Comma. Let me make use of the nj as well. So this is equivalent to the j plus dy of d. So this is also fine. Now let's do one thing. Let me go with the if condition here. If ni greater than 0, n j greater than or equal to 0, this is also fine. And ni, so this one less than n, and nj less than n, and this one m of ni, this one also nj basically, right? So this is fine. So then what we need to do here, so we have to merge the adjacent empty cells as well accordingly with the criteria of the question. So I'll just go with union of, so we have written the union helper method as well as we are making use of the DSU here. So this one will be making use of it here. Union helper method ID of I comma j, right? So this is fine. So we are going with the union by sizes, right? So this one will be ID of ni comma nj, right? So this is fine. Yeah. So again, if you don't know the disjoint union set, this one set union algorithm, please go through the this one algorithm. So it's present in the graph algorithms playlist, right? It's in the programming language Python. It doesn't matter. You'll understand that one. Same goes with this one. What do we call? The approach remains same for same within all the programming languages, right? So I insist you to go so that you understand the code better, right? So while we write, so it will be easier for us to solve the problem, right? So when we understand the algo, so this is fine. Let's move on with the further things. So I'll just come here. Let me come out of this one entirely, not this one entirely, right? So this is fine. So let me move this one a bit. Yeah, now this is fine. Now let's do one thing. We are left with certain things. So we have to recompute the component sizes. Nothing but we need to reset the size and count real sizes per root. So I'll just go with arrays dot fill here. This one, let me pass size along with a 0. Right. So let me go with the for loop here. This one int I equals 0, I less than n. So let me go with I plus plus. So this is fine. Again, let me go with the for loop here. So this one int j equals 0, j less than n. So let me increment the j. Now let me go with the if condition, man. If m of I j, this one, then let's go with size of this one. What do we call? Find here. This one find of id of, let me go with I comma j, I comma j. This is fine. Yep. Now let's do one thing. Let's initialize mx the k into k. This is fine. Yeah. Now let's do one thing. Let's slide the k into k square over every valid top left. Nothing but the I comma j. So I'll just go with two for loops over here. So this one will be int I equals 0, I less than or equal to n. So this will be I plus plus. So this one has to be n minus k, I believe, not n. I hope this works. Let's see. We have to go with the n minus k itself, right? So we are just sliding over the k into k square over every valid top left. So we have to consider k. Yeah, this will be n minus k itself. So now let's do one thing. Let's initialize inside counts for the first window column. Nothing but j equals 0 for the rows I to this one, I plus k minus 1. Right. So again, we have to go with two more for loops here. Right. So this one nested loops. So I'll just go with for here and x equals 0, x less than k. Let me go with x plus plus. Let me go with one more for loop here. For we have to go with the y as well, right? Y equals 0, y less than this one is k as well. So let me go with y plus plus. Now let's go, let's increment the inside count for any component cell, right? Any component cell that lies between, that lies inside the square, sorry. So how can we write that one in the form of code? So we have written the inc helper method for that, right? So I'll just go with the I plus x here. Along with it, let me go with y, comma, 1, right? So this is fine, man. Now let's move on with the for loop. Again, this one, I'll just go with for here. J equals 0, j less than or equal to n minus k again. J plus plus. So within this for loop, what we'll be doing? So let's go with the sliding window one column right. So when I say sliding window one column right, so what we will be doing here, we will be removing the previous left column and then we will be adding the new right column to it. That's what we will be doing. So for this one, we'll be making use of the sliding window. Now let's do one thing. How can we write this one in the form of code? So suppose if j is greater than 0, then let me go with the for loop here for int p equals 0, p less than k, p plus plus, right? So this is fine. So within the for loop, what shall we do? So I'll just go with the inc helper method here. So this one will be I plus p comma j minus 1. So this is also fine. And this one will be minus 1, right? So we have to remove the column j minus 1 from the inside. Next, let me go with the inc. This is 1. This is fine, sorry. So this one will be I plus p comma j plus k minus 1 along with the 1. Yeah. Now let me come out of this one entirely. Next, what we will do, let's go with the answer variable. So let's go with the base contribution in simple terms. So all we have to do here is we have to consider all the k into k cells inside the square, right? Inside the square, basically, yeah, that becomes empty, right? So that becomes empty, right? So let's do one thing now. Mm, Assign answer to k into k. Next, let's do one thing. Let's move on with the further things. Let's add the sizes of the neighboring component without this one double counting or counting inside the cells, right? So for this, let me go with a iteration part for loop. This one in p equals 0. This is fine. P less than k. This is also fine. Let me increment p here. Now within the for loop, let's go with the top this one. What do we call top parameter neighbors, bottom parameter neighbors, left parameter neighbors, as well as the right parameter neighbors. So how can I write this one in the form of code? So let me write this one first one and make the necessary changes. First, let's go with the top. Then we can go with the bottom, left, and right. Right. So first, let me write the top and copy and make the necessary changes. So this one will be answer equals answer plus add of this one will be I minus 1 comma j plus p, right? So this is fine, man. Yeah, let me copy this one entirely. So here this will be paste this one, paste this one, paste this one, right? So this is fine. Answer equals answer plus I plus k. uh this is fine, this is fine. So this one will be j plus p. This remains same. Next, let's go with a I plus p, and this remains j minus 1, right? So let me go with j minus 1. Yeah, this will be answer equals answer plus add of this one I plus, let me go with I plus p this time, right? So this one has to be, sorry, this one has to be actually I plus k, and this one has to be I plus this one. What do we call I plus p basically? Yeah, this is fine. Then j plus p, j minus 1 we have considered for the left parameter neighbors. Finally, for the right parameter neighbors, we have to go with add of I plus p we have considered along with the j plus k. Plus k. This is fine. So let me come out of this one entirely. We are done with that part. Let's update the global maximum as well as let's clear used markers for the next square, right? So we have to move on with the further things, right? So first let's update the global maximum. So this one will be mat.max, mat.max of this one. What do we call max along with the answer? The next part would be, let me go with a clear, right? So let me go with the clear. So let me come out of this one entirely. Now let's reset the inside counts before moving to the next row of the top left. This one, what do we call top left positions, right? So I'll just go with the arrays dot fill here. So let me go with arrays dot fill of inside comma 0, right? So this is fine, man. So let me come out of this one entirely. Finally, we have to print the answer and flush the output, right? So I'll just go with out dot println. This is fine. Somewhere I have made use of the bracket wrong. God can see me here. This is fine. Mx as well as the we have to flush, right? So either you can go with a flush or close. I'll just give flush here, make use of the flush. So we are done with the code basically. We are done with the code. So somewhere I have done something wrong, man. Bracket I'm speaking of actually. I have misplaced the bracket somewhere. I don't know where. I have misplaced this one brackets actually. This is fine. 1 second, just give me a second here. Mm, 3 follow-ups we haven't. Yeah, okay, we haven't considered brackets for this. This is fine. Then we have considered 4 brackets, so this is also fine. I went with the three for loops here, right? Yeah. No. So did I miss anything, man? Yeah. Internet. Yeah. So this is the main cause, man. So let's do one thing here. If not of m of ij continue, I have written here, right? So we are considering only the empty cells here. After that, to move further, we have to make use of the for loop. Directly, I have went with the initialization. So this one has to be for int, basically d equals 0. This is fine. D less than 4 as we are exploring the four directions, right? So we are going with a union adjacency empty cells to form the components. Basically, we have to go with four directions. So here d less than 4, hmm, d plus plus. We are starting with 0, right? D plus plus. So let me open the bracket here and let me close this one over here. This is fine. Yeah. Now it's good. I have completely forgotten that one. Let's do one thing. Before checking the code with the different inputs, this one inputs are the examples. Let me copy paste the signature starter template. Let me come here. Let me paste this one over here. This is fine. Yeah. Now let's do one thing. Let me copy this one entirely. Copy this one entirely, or I'll do one thing. Let me copy this one. We have to check this one code with the different inputs, right? There might be this one errors of the works. We run this one. So many errors, man. 119. Where is this? So this has to be int, I think. We are assigning this one here, right? So this one, where it is, we are going with a, and just give me a second here. One second. Just give me a second here. This one has to be int. Let me. Still, we are left with six errors. Error not a statement. Int of int we are considering for this. Where is this? Line 124. What we are doing there actually? Eh? 124, right? So this one we have went with, one second. One second, one second, one second. Yeah. So this one is fine. We are going with the three for loops here. This is also fine. So this one we are making use of INC helper method we have made use of, right? So this one, where it is? This one actually. Yeah. Let me run this one now. Yeah. Three errors are gone. So error incompatible types missing the return values. So this, whether this has to contain the value or not. Line number 37. So let's go with 37 here. 27 is fine. Within the which method? 37 static void within the union method. Okay, so this void has to be v has to be small. Now let me run this one. We are left with two errors. Uh, incompatible types missing return value. Same thing again, I believe. 56. 56 static int add. This is fine. We are just going with a boundary check this one, right? What's wrong here? We're just going with the add helper method. Let's check what we have written here. Add. So we are going with I less than 0 or j less than 0. This is fine. We are going with a boundary check. I shouldn't be greater than or equal to n. That also we are checking. And this one, or j greater than or equal to n, right? So, oh, we have to return something right here, not exiting basically. We have to return 0. Oh my God, sorry. This is fine. We are left with only one error. Incompatible types int cannot be converted to the int. Somewhere I have this one assigned, this one arrays. Comp new int 199. First of all, just give me a second here. Yeah, we have made use of this one. This is fine. So let me go with the line number 93 here. 93, 93, 93. Where is this 93? So this one we are assigning here, right? Right. Yeah, again, we have went with two arrays basically. By looking all this one, I have written n into n itself for this one as well, I believe. So this one has to be n and n separately. Ah, now let me run this one. Yeah, we are getting the output 10. Now we have cleared all the bugs. We are getting the output, perfect output, right? Desired output basically 10. So let me copy this one. Let me paste this one over here. We have to get the output 25. Yeah. So we are getting the correct output. Let me copy this one entirely. Now let me hit the submit code. Let's wait for some time. Let me choose the E, right? So let me paste this one over here. This is E itself, right? Yeah, 680 E. Let me submit this one. I hope this works for all the test cases. Let's see. Let's wait for some time. Let's wait for some time. Yeah, wrong answer on test 9. What's wrong here? Let's check what is wrong here. This one. First number differs. Expected 58. We are getting the 55 actually. Have you done anything in this one? Assigning the empty. This one. What do we call? Empty cell actually. Let's check the same. Just give me a second here. So this one actually might be the error in the this one. DOC merge loop, right? So let's check the same. Come here. There we have it. This itself, right? Number 103. So this one actually, DOC merge one. We have made use of the helper method union. This is right. We are going by this one. We are going with union by sizes, right? So this one, let's do one thing. Yeah. Yeah, this one bound. Oh, this one has to be ni greater than or equal to 0, I believe. Let me copy paste this one. Yeah, this works correct. But let me check this with input one. We have to get the output. Expected this one. Output is 55, but we are getting 58, right? Not this one. We have to get 58, but we are getting this one 55. Let's see whether we get 58 or not. Yeah, now we are getting 58. Mostly this is the wrong thing. Let me copy this one entirely. The DSU merge loop, we were getting the error, right? So this is fine. Just give me a second here. Let's wait for some time. So yeah, let me choose E here and let me paste this one and hit the submit button again. Only one change. So in that one, within the DSU merge loop, I have given ni greater than or equal to 0, right? So this is fine. And now this has to work in my opinion. Let's see. I hope this works, man. Code is big actually. In debugging becomes difficult. Yeah, this is running on the test tool, right? This is fine. Yeah, that was the mistake, I believe. So you can here you can clearly see in the toast it is showing accepted, right? So the verdict that we got here is accepted, right? So whatever the code that we have written works absolutely correct for all the test cases, man. So we have purely made use of the this one DSU here, right? So we have purely made use of the DSU, right? Find and the union methods along with the some more helper methods, right? This one add, clear, as well as the INC and ID, right? So mainly we have went with a DSU, this one to solve this particular problem. Disjoint set union to solve this particular problem, right? So I hope again the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.